Hello and welcome. Today we're going to discuss about joins and subqueries. Now, before getting into joins and subqueries, what are joins and subqueries? Let us firstly understand then why do we need joins and subqueries. And before understanding that, we will be covering joins, their types, and the types of subqueries in this coming module. Now, coming to the very first question, that why do we use join and subqueries? Now, if you ask me, if you give me a simple business problem and you say that you have various different tables and now you want to get a combined result from two different tables. Like for example, if we have an employees table, which have all the details of my employees and a department table. Now, how can I find out that which employee is working in which department? How can I combine these two tables? So in this module, we're going to learn about that how can we use joins and subqueries to find out different meaningful data out of these two different tables. Now coming first to that what are joins? Now as the name also suggests here that joins simply means joining two different tables. As you can see, if you have a table 1 and you have table 2 and now you want to join these two tables, you want to combine these two tables so that you can get the combined result from both of these two tables. Then we will use join. Now simply as you can see, join means simply the cross or the Cartesian product of the tables plus the conditions that you specify. Now we know that what is Cartesian product. Like for example, if we have, let me zoom it a bit. So if we have, we all know that in our mathematics, like if we have a set A, which is 1 comma 2, and another set which is A comma B, then simply the Cartesian or the cross product means that every element will be um, joining the every other element of the other set. Like for example, let me write it cross product. Now the cross product of both 1 comma 2 and A comma B will be simply every element to the every other element. It will be 1 comma A, 1 comma B. That means the very first element has been joined with other two elements of the other set. Similarly, it will be repeated for the other element as well. Now this is simply our cross product or Cartesian product. Now joins leverage this mathematical functionality and similarly they combine the rows that we have in our tables. And after combining those rows based on the conditions that we specify, that okay, that out of these many combined rows, in which particular column I am much more interested in. Like for example, in this example, if I want to know the location of every employee who works in department 10, then I'll simply join them and I will specify the condition that okay, the condition is I want to know only about the employees of department number 10. That means if Clark is working in department 10, I just want to know its location. Then I specify my condition. So this is how joins helps you. Now the only condition for joins, that means if you ask me that okay, which two tables can be joined together, then as you can see the condition is that both tables should be having some common attributes. That means both the tables must be linked together. And it is also making sense by like if you have totally different tables, they have nothing in common. Like for example, if the table talks about the manufacturing of chocolates and the second table talks about the employment or it works about the roll numbers of the students in any school. Simply the manufacturing of chocolates had nothing to do with the roll numbers of a student studying in a school. Right? So I'm just giving a simple example. But when it comes to SQL, both the tables should be linked in a common attribute. That means they must be having a foreign key associated with them. Like for this particular example, as you can see, department number is working as a common attribute. Our employees table also have a department number And our department table also have a department number. That means this particular column is common and it is acting as a bridge or a link between these two tables. Now, having understood about the joins and the condition for joins, let us know about what is the syntax of join. Now, because there are various different kind of joins which we're gonna explore later, the simplest syntax of join is that you have to firstly specify the okay from which table you want to join the another table. And then you have to specify that okay from first table which join type, inner join, left join, right join, full outer join or cross join on the second table, and then you have to specify the condition. Okay, so if you ask me that okay I didn't get it fully, then you will get it fully as we're gonna explore about inner joins. Like as you can see in the diagram also, like if you have two tables and out of those two tables you want to know about the common attributes. That means you want to know about okay what are the common rows in both table 1 and table 2. Then you can find out by using inner join. And the syntax for it is very simple. As we know that if you want to get out any columns out of a table, then we have to specify that under select statement. Then similarly, we have to specify that okay, whatever columns we want under the select tables, select clause, and then from which table we want it, like from table 1. And then we have to join table 2 on specific join conditions. Like for example, if I ask you that okay, we have two tables. The very first is our employee table as you can see from here, and the second one is our department table, right? This is our department table. Now if I ask you that okay, can you find out all the employees who have been assigned the departments? That simply means that okay, as you can see there are various employees who haven't got any department as of yet. They are still waiting for their departments to be assigned, right? Then you can help me only find out those employees who have that departments. Then you can do that by using inner join. That means you are asking me for the common columns. That means you are asking me that okay, what whoever have got the department and whoever is the employee, help me find out those. Then you can simply find out by using inner join in this case, because inner join will help you to find out that okay, how can you help? How can we find the both the employees and department? Then you can simply find out by using inner join. Now, as we know the syntax, that the syntax is simply you have to select whatever columns you want and then from which tables you want that, and then you can simply specify that, right? So you can do that by using inner joins. Now um, if you ask me that okay, I want to know about each and every information of my employees from the employee table, I said okay, and I only want to know about the employees that have departments being assigned. Then what I'll do, I'll simply do inner inner join, and then I specify that okay what table name I want. So I want to inner join department table. And then if you remember that we have to specify a condition. Now we know that the only common attribute between both of these is department number. Department number is present in the department table as well as the employee table also. As you can see, department number is present in both of the tables. Then we have to specify that okay, whenever the department number of the employee table equals to the department number in the department table, based on that condition, join both of these two tables, right? So after writing this simple query, we'll be able to join both of these two tables. Like for example, if you can see that we have our employee number, employee name, job, migration, hire date, but we do not have the department name specified over here. But after running this particular query, we'll be able to see the department names as well, and only for those employees who have assigned departments. Because as you know that right now Komal does not have any job. So if we execute this query, as you can see here, you can also find the department names. But earlier, when we select the employee table, it was not present over here. That means what we simply did, we combined both of these tables. And if you know, if you pay some attention, then till here we have our employee table. As you can see, e-name, job, migration, and department number. Then these department numbers come from the department table. So it reiterates that we have joined both of these tables, right? So it was a very simple example that how can you use inner joins. And if we move ahead, that okay, I understood that if we want to find out the common attributes of the join of both of the tables, then we have to use inner join. But what if I want to know about each and every column of table 2 in addition to the common columns which is present in table 1? Then how can join help me? Then for this particular scenario, you have your right outer join. So your right outer join, it returns the row for the matching values, that means the common rows, as well as the whole of table 2. Now the syntax for this is also very simple. Here you have to simply select that whatever particular columns you are interested in and from which table, and then uh, from which another table you want to join this. Then you have to simply specify that and on which conditions. Then by using right outer join, you can simply do that. Now, if you ask me that, okay, I understand all of these things, but can you help me to find out the how actually your right outer join helps you? Then we can specify that as well. Now, if I want to find out all the departments and their respective employees, or simply I can say that okay, help me find out that okay, what is the department of let me find out of Smith, like, like if I want to find out okay, what is the department for Smith, then I can simply find out that. And for this, I simply have to select that okay, whatever information do we need to have our employee name, we need to know about the job, and we need to know about the salary and whatever columns you want to specify and from which table you want that. Then I want all of this from employees table. Okay, then you'll say okay, and after that I want to know only these columns from the employee table, but I want to know each and every column from a department table. Then what I'll do, because I want to know the common attributes and the full table from the right hand side, it is the table, the department table, then I'll simply do right join department table, and on which particular conditions I want this join to happen. Then as we know that the only common attribute between both of these table is our department numbers, then we simply specify the department number should be equal. And now because we are only interested in knowing about Smith, we can simply find out okay, after joining this, find whenever we talk about Smith. So if we run this query, oh, we didn't specify the department name. So we have to specify the department name also, and then we can run this. So as you can see, Smith belongs to the research department. Now, if you ask me that, okay, is it necessary to join this table? Can't I specify without joining this table? Well, if you try to specify this particular thing without joining both of these tables, then you will simply get an error. So let me also show you that. Like if I comment out this part, and then if we simply run this query, then we'll be getting an error for department name, because right now our employee table does not contain the department name. And if we try to run out, then it'll simply get us error. As you can see, department name cannot be found. So for these particular reasons, we need to join the tables. As soon as we join the table, as soon as we have combined the tables, now based on our specified conditions, we can find out that, okay, which particular thing we want to know about. So this was, you can say, a simple application of our department, our right outer join. Now if you ask me that, okay, I understand that, okay, right outer join gives me all the information from the table 2 and the specified and the common attributes from both of these tables. But can I get something, that means can I get something which gives me all of the rows from table 1 and some common rows from both of these? Then we can do that. We can, and for this we have left outer join. So left, it joins, so it returns all the matching values in the joining columns from both of the tables, as well as all from the left hand side. Now the syntax is very similar to right outer join, but in the right outer join we have to simplify right. Here we have to simplify left. So we have to select that, okay, whatever columns you want, from which table you want, and then to which particular table you want to join on which specified conditions. So here, as you can see, we are joining table 2 and table 1. So we can simply do that by using left outer join also. Now if you ask me that, okay, um, till now we have discussed about that, okay, can we get the common attributes? So we can get the common attributes by using inner join. If you want the full right hand side table and you want plus the common attributes, then you can simply do right outer join. If you want to know about the full columns from your left table plus the common rows from both of the tables, then you have to use the left outer join. Now if there is any way from which we can find out the full tables, that means all of the rows from table 1 and all of the rows from table 2, then you can also specify it by using full outer join. Now by using full outer join, you'll be getting all the rows from both of the tables, right? So you'll get your, so for the syntax for this is also very simple. You have to simply select whatever columns you want, and then you have to specify the table names, and you have to specify full join table 2 on which particular condition. So let us also see the example for syntax for this. Now once we have learned the syntax of all of these things, we'll simply um, compare all of these the results of all of these joins as we move ahead. Like if we want to select everything from our employee table and I want to fully join, I want it to join it with my department table, and we know this condition will be same for all of the joins, then the department number should be same, because the department number is a foreign key in my employee table, but it is working as a primary key in the department table. Hence, it is working as a bridge between both of these tables. So what is saying? It is saying that select all of the columns from employee table and all of the columns from the department table because there is a full join. So full rows will be displayed, and on this particular condition, all of the full rows will be displayed. So if we execute this, as you can see, we get each and every value. So as you can see, we also got the departments like operations department, which does not have any employee. Then also it is being displayed. Why it is being displayed? Because we have specified full outer join. So whether the employee have been assigned the departments or whether the vice versa is true or false, this particular join type does not cares about this. It will simply returns all of the rows from both of your tables. So as you can see, the null part is also being added over here. But for in the case of inner join, you'll not be able to find this employee name to be null. So let me show you that as well, so that we can clear our difference between inner join and full join. So as you can see, this is our particular inner join statement. So when we run this, as you can see, there is no employee name which is null. Every employee name is being filled with any name, and all of the departments are there. And as you can see, you'll not be able to find the operations department. The reason for this is because our operations department does not have any employee being assigned. So as you can see, the difference between inner join and outer join. Inner join is only returning the employees which have been assigned the departments. That means the rows which are common in both of these tables, from employee and department tables, the rows which are column is being um, given back by our inner join, while full join is returning both of the rows, all of the rows from both of the tables. So this was a very simple example of a full outer join. Now there's also certain conditions where we need to implement the cross product. Like if we have two tables, we want each row to be combined with every row of our other table, just like we do in our cross products. So for this, we also have a join type which is known as our cross join. So as you can see in the table, that each and every record that we have in both of the tables get combined with every other record. That means our record 1 will be combined with record 1 of table 2 and record 2 of table 2 as well. Now simply the syntax for this is that okay, whatever columns you are interested in, you simply put those column names under select statement. You specify the name of your table and then you simply specify cross join, and then you can simply do that. Now there is also another way of doing cross join where you can simply you can write select whatever columns name you want, or you can put a star, that means each and every column, and from which table. So you can specify the table names by putting a comma. So we have two simple syntaxes for cross join. Now if I want to show you okay that the example for cross join, let me find a space for this. Yeah, so if I want to select each and every column from my employee table and I want to cross join it, that means I want its each and every row to be combined with my department table, right? Then how can I do that? I can simply cross join them. So again I have to specify a condition, amp dot department number. So again you have to specify the department number. Now if you simply run this, let's see what happens. Oh sorry, So now you'll also be getting the null employee. So as you can see, you are getting everything. Now it is hard for us to actually find out, okay, is it really being cross multiplied with each and every row for my department table? Then we can easily find out by using by filtering its result. So let us filter its result. So I say that, okay, whenever the employee name is this, then show me the result. So let me run this query and find out. So as you can see, in the department table, we have 7 columns. Now as you can see, one simple row, the row which contains Ananya as a name. So as you can see, there is only one row which contains Ananya as a name in my employee table. And this particular row has been multiplied to all of the 7 rows of my department table. So simply we have done a Cartesian product or a cross product, and which can be simply find out by filtering the results. So by cross join, you can simply cross product or you can do the Cartesian product by using that, right? So this was simply about that. Okay, what are the different kind of joins? Now to give a quick revision that, okay, what are the different kind of joins? Let us run all of the queries one by one. Now if I ask you that, okay, how can you find out all of the employees who have been assigned the departments? That means I am asking you that do not return me any of the employees which are which is not having any departments. Do not return me that. And I'm also not asking for any of the department which does not have any employees in there. Like if the department name is null, do not return me that. So if I'm asking you for a common attributes, then for common attributes you simply have to hit your inner join. So whenever you run your inner join, you'll be getting the common attributes from both of the tables. Now if I ask you that, okay, give me every row from my right hand side table and the common rows of the left hand side table, then simply you have to run your uh, right outer join. And for the reverse case, when you want every row from your left table and you want only specified rows from your right table, then you can specify the right outer join. Now if you want both of the rows, you want all of the rows from both of the tables, then you can simply specify your full outer join. Now if you ask me that, okay, if I want to do a cross product, then you can simply do your cross joins. Now the type of join also as you can see that it also affects the number of rows that you get. Like if I do the inner join, then I'll be getting less number of rows because the result has been filtered out from me. So I only getting 16 rows by using inner join. But whenever I do a full outer join, the number of rows will be increased because now I'm not doing any filtering. Now I'm asking that, okay, return me each and every row. So as you can see, the number of rows is increased to 18 because there is no departments. There are 2 departments which does not get any employees. So based on joins, you can specify that, okay, what particular value you are much more interested to know about. So joins are one way to uh, combine 2 of the tables, to combine the results of 2 of the tables. Now there is also another way of combining results, because there could be a way, like we know that in the where clause, in the exist clause, or in the in, like if we specify that, okay, where in where the department names are in certain values, we don't know the value, but like means we when we don't know the value exact value, but we know the query which will help us to find out the which will help us to find out the value, then for those kind of situations we use subquery. Now a subquery simply means that if you have a query, now uh, inside that query under the select statement or the insert, update or delete statement, you can specify any other query. Like for example, if I have my simple query, if I say that okay, select everything everything from my employees table, and where now instead of specifying any numbers, like if I so instead of specifying any department numbers or any other attribute, instead of specifying that, I'm just simply specifying any other query, because I don't know that what the exact value for department numbers are there, but I can know about that. Okay, I know a query which will help me to find out that what are the particular department numbers, and I can simply find out by using my subqueries. So I can find out my distinct department numbers from my department table. Department table. So what will happen is that, as you can see from the diagram, that you can have multiple subqueries inside a subquery. That means you can have a main query. Inside that you can specify a subquery. Likewise, that I did, like my this query, which is select star from the employees table, is my main query. But the other one which is specified is in brackets is my subquery. So what will happen is the result of this particular subquery will be given out to my main query. And after receiving the result from the subquery, it will execute my main query. So as you can see from the diagram, the results from a subquery first get into its main query, and then finally the result is being displayed out to the user. So, right, I hope I made this point clear. Now you can use your subqueries inside a select statement. You can use that under insert, update, delete statement, or any other statement. Like for this particular example, I have used them inside my where clause. That okay, where instead of specifying the department numbers manually, I know the query, I simply wrote that query that okay, which will be getting me department numbers. Now there are various different kind of subqueries as well. So because we know that maybe a query may give you one single answer, maybe it gives you any number. It may depend that okay, your query may depend, you may give out you um, various number of results like 5 or 6 results. Now for those based on the results that you have various types of queries. Like you have a single row subquery which returns 0 or one of the row. The another one is your multiple row subquery which returns one or more values, and the third one is your correlated subquery. Now your correlated subquery um, depends on your parent query for running. So we'll see all of these things. So as we have seen that okay, how can we use subquery? Let us do certain questions so that we can actually solidify our understanding for subqueries. Now if you ask me that okay, if you ask me 1 minute. Now if you ask me that okay, there's a question which asks me to display all the names and the job titles for all of the employees with the same job as Jones. Now I know that okay, mm, so I know that okay, I can get the names and the job titles from my EMP table or my employee table. As you can know, as you can see, the jobs and the name is specified in the employees table only. But if I want to know about that, I'm not sure what is the job of Jones, but I can write a query which can help me to find out that okay, in which particular job Jones is working right now. So I'll firstly write that query. I know that I can simply select my job from my EMP table, which is my employees table. And because I'm interested in knowing about the jobs of John, then I can simply specify a filter That means I can specify that, okay, where the employee name or ename equals to John, then only give beam back that query. Oh, it's Jones. Hmm. So if I run this query, I'll get to know that, okay, what is the job for Jones? So he is a manager, simply. Now because it is asking me to display all of the names and the job titles of all other employees who have the same job as Jones. So instead of writing two queries, I can simply use a subquery in this case. Once I know that this subquery will be giving me out that whatever I need. So I can simply select the names. Okay, one second. Name and the job from my employees table, where job equals to my subquery. Right? So what will be happening right now is that firstly, behind the scenes, this query will run, and this query will find out that what is the job for Jones. And after this query is completed successfully, it will return its result to my main query, and then my main query will filter out the results. Like if I run this simple query, I'll find out all the employees with their jobs. So as you can see, we have Jones, we have Blake and Clark working as a manager. So what happens is we know that with this particular subquery results return the result as manager. And once it is put inside the where clause, my where clause will be filtering out the employees table and will be extracting the names and the jobs of those employees who have the same jobs as Jones. So this was an example of a single row subquery. So because this subquery only returns a single row, I can use it with equal to sign. But what happens if my subquery, if I want to know something more? Like if I want to list out the employee details who earn the highest salary for their jobs. So as we know that there are various jobs. There is a salesman, manager, analyst, president. So if I want to know that, okay, display all of these different jobs with their highest salaries. Now what can I do that? What can I do in that particular case? So in that particular case also you can run a subquery. You can make a subquery. But this will require a multiple row subquery because we don't want to give out one single row. We want to give out various different jobs which is being assigned in the employees table, right? So firstly, we'll write a query that which will help us to find out that, okay, what are the different jobs available. So for this particular case, what we'll do to find out the maximum salary, we'll simply use a built-in max function. So we'll select the maximum salary from our employees table because salary is being included in our employees table. As you can see over here, that salary is included in our employees table. Now to find out the maximum salary, we'll use the max statement. We'll use the from clause of employee table, and because we want to know the highest salary on base of the respective departments, so we'll group them by department number, right? So what will group by help us? Group by will help us to filter out and to group together the result. So you can simply find out the department number. Now it will be returning more than one values, as you can see. So based on the department number, it is returning us the value of 5000, 3000, 2850, 5000 and 5000. So these are various department numbers. Like if I want to also show you the department numbers, department number, let me execute that. Yeah, So for department 10, you have this highest salary. For department number 20, this is the maximum salary for 30, 50 and 60. So based on this, we can find out, okay, what is the maximum salary? But we want to use it as a subquery. Then simply we can use it by a subquery. We all know that we have to simply put brackets over here. We can simply put brackets and then we can nest it inside any other query. Like if we want to know about that, okay, we have to know about the employees details, then we can simply do select a star again from our employee table. But this time, because we want to filter them on the basis of their salaries, so we simply say that, okay, wherever the salary is. Now one thing to note here, because this particular subquery is returning us more than one values, then we can't specify a equal to here, because whenever we specify a equal to, that means we know that equality or equal to sign is meant for only one single value. But if we have more than one value, then equal to will be giving us error. So let me show you that error as well. So because as you can see, the error is the subquery returns more than one value. So whenever you have more than one value or you have a multiple row subquery, then in that case you don't have to use an equal to sign. In that case you can use in, or you can use any or exist. So you can use these kind of operators. The operators we can which allows you to put in multiple values. Like we know that we can use the we can use the exist operator to know about whether it exists or not. We can use any, and then we can use any other operator like greater than, equal to, like we can use our greater than or less than, or we can use greater than, equal to. So various different signs we can use by using any operator. So whenever we have a multiple row subquery, which that means the subquery which returns multiple rows, we have to use such kind of things which accepts multiple rows. So after replacing equal to with in operator, if we run this query, we'll be getting our result. So as you can see, this is our result. So we are getting each every so this particular subquery. So this is also an example of multiple row subquery. Now there's also a third kind of subquery which is known as your correlated subquery. Now it is a subquery that uses value from your outer query. That means both of these subqueries are related to each other. And your correlated subqueries are used for row by row processing. That means each subquery is executed for each and every row for the outer query. So let me clear this with an example. So right now, remember we did this question by using joins. So if you want to find out all the employees who works in a department, we can use join in this particular case. But we can also use a subquery to do this particular solution for solving this particular query. Now we can simply do that. Okay, we want to firstly find out all of the departments, right? Then we can simply find out. Then we can say department number. Oh, sorry, department number from from departments where my employees department number is equal to my department, the department number present in my department table. Now this particular query will fail. The reason why this particular query will fail, because here we have specified the department table in the from clause, and this particular row is unknown for our query. So If we run this, it will simply give us an error that it is not able to find our EMP department table, as you can see. But if we nest this query inside a correlated subquery, now how are we gonna nest it inside a correlated subquery? The answer is very simple. Firstly, you have to join the two queries. You have to join your main query and your subquery together. How are we gonna do that? We'll select a star from employees. Now here you are gonna do a condition of of where exists exists. So right now what I'm specifying is that okay, give me all of the columns from the employee table whenever the department number is same as the department number in my department table. So as you can see, earlier when I individually run this query, it is giving me an error. And if your subquery is returning an error, your main query will not successfully complete. We all know that. But because it is a correlated subquery, my this subquery is relying on the from clause from my main query to get the result of this department number from my employees table. So let us run that and find out. So as you can see, now this query successfully ran. So what actually happened is that the very first point for correlated subquery, your inner query or your subquery depends upon your outer query. So as you can see, though we have not specified our EMP or employee table in the from clause of the subquery, then also the subquery is able to identify that because it is being related by using the from clause and the where exist clause. So it fulfills the condition for one of the subquery, one of the conditions for correlated subquery. That both of the tables should be having a relation, a dependency over one another. The second condition is that by using exist clause, what we actually we know that our exist clause returns true or false based on the query. Like for example, the department number is 60 in the employees table, and if this particular query also returns department number 60, then it will be matching that that one value with each and every row for my employees table. So firstly, it will check that okay, if this particular subquery returns department 60, then it will be checking that okay, whether the my row number 1 is equal to department 60. It will say yes, true. Then it will return the employee name Komal and all other values for Komal. It will ask that okay, whether department number 40 is present in my employees table. It will say no, there is no department number 40 in the employees table, and as you can see, there is no department number 40 in the employees table. Then the exist statement will return false, and that particular row will not be displayed in my result. So by using this particular thing, I created a correlated subquery. So coming back to the conditions, that whenever you have only single row query, that means your subquery will only return a single row. Then for that you can use an equal to sign. But if your query returns multiple rows, then for that particular condition you can use your any, all, or your in operator, or your not in operator. So you can use all of that by using your multiple row subquery. But if you want to relate them, if you want to define some kind of dependency between both of your subqueries, for both of your main query and your subquery, then you can use a correlated subquery in that particular case, as we saw in this particular. Then individually this particular subquery is returning an error, but whenever we run it as an correlated subquery, it is successfully able to give us the result, right? So I hope you like this, and thank you.